These projects are designed to cultivate multiple skill sets that complement a series of videos created for the purpose of acquiring a foundational knowledge of the Python programming language. These projects will cover coding both console-based and GUI applications. Tkinter is a Python binding to the tk.GUI toolkit, and its framework is built into Python's standard library, so it does not require the installation of any additional modules. This makes Tkinter a convenient choice for building graphical interfaces for Python applications. All source code in these videos is available at the 1byte@time GitHub repository. You will find a link to the code used in each video beneath it, in its description and comment section. You may use these links to download the source code.
Here's another simple but fun Python Tkinter project. Today we're going to build a simple networking tool. Nothing like Nmap or Zenmap or Netcat or K.Enable, but it's going to do a simple ping sweep and a port scan and get the host network information. To do so, we're going to make use of the socket module to get some network functionality.
Please note that you will almost always want to implement multi-threading in your Python Tkinter applications that utilize repetitive or resource-intensive processes.
And as always, whenever we're doing something that involves a loop, or CPU-intensive or repetitive, iterative type of process in a Tkinter application, we're going to want to implement multi-threading. Why? As in previous examples, remember that everything in a Tkinter application runs in the main loop. All the widgets, they listen for events and triggers, and they handle them in that main loop. So if you launch any type of function or method that involves looping and sort of a process-intensive behavior, then it will lock up the Tkinter graphical interface. So your windows, your frames, your widgets, they won't respond to the end user. They'll be locked up until that iterative or looping process finishes. And then finally they would become available again. So to prevent that, a lot of times whenever you code a Tkinter application, you're going to want to implement multi-threading to prevent that from happening. And remember, as we've said in previous examples, GUI programming with a graphical interface, it's a completely different type of logic, a different type of thinking. It's event-based programming, based on triggers. You listen for the trigger. When you hear the trigger, then you go execute an event handler, and that calls other methods and functions or does something. But it's based on how the end user interacts with your interface. It starts with the GUI or graphical interface, very different from console programming, where you can sort of control and shepherd the end user where they go in different loops and processes. That being said, let's take a look at it and see what it does.
The Python Tkinter GUI.
So let's run our Tkinter application, see what it looks like and what we're going to build. Called it Purple Python Port Pinger because I wanted to use all P's. And I just added to the menu up here, get network data. Does the same thing as this button here. It just gets the host's graphical information. And what we're interested in is down here under the wireless LAN, because I'm on my home network and I'm connected to a wireless access point router. So in this case, this is the information that I want, my IP address, subnet mask, and so forth. And then also I've got the external network, host name, and then my gateway, my subnet mask, and DNS server here. It just lists this here when it loads, okay? So notice if I click back and forth between these two frames, these labels here, it disables or enables each one. So the first thing we want to do is see what's out there on the network. Before we can do a port scan, we need to find some live IP addresses, some active IPs. And I want to stay within the network range of my network. So I'm a Class C network, and my IP address right here, my IP version 4 address is 10. So I'm just going to do 1 through 15 because it would take a long time and my network is small. I don't have that many. But I'm going to start at 192.168.1.1. Okay, so we'll look at my router, the gateway, and whatever other devices happen to be on my tiny, teeny weeny home network. So I'm going to click Initiate. And notice while it's doing this, it's running in a loop, and that's an intensive process, sometimes listening for echo replays, but my interface remains responsive because it's running in a separate thread. It's not running in that main loop, so it doesn't lock up my GUI, even though it's doing a CPU intensive, iterative type process. So again, that's the reason why you want to do things in separate threads when you get into tk.Enter programming with Python. So I have a few live hosts on my network here. Okay. And that's my cat Sebastian. He's walking around the house, wandering, meowing, because he's 17 years old and has dementia. He forgets where he is sometimes. So do I. Maybe I have dementia too, huh? I don't know. Alright, so anyway, we have a few live hosts here. Okay. So now we have something to port scan. So I'm going to click down here, and it enables this frame, this label, and disables the one up here. So for port scanning, I want to pick a valid address. I'm going to pick this last one here, 192.168.1.5. That was a live one. All right. So 1.5. And for active addresses, I'm going to do 20 to maybe 81. Or we'll say 82 just for the heck of it. Okay? 20 to 82. And these would be ports, like 21 for Telnet, or 23 or FTP, or 80 for a web server. Just typical ports that might be open on a device. And we're going to scan for those ports on this live IP address here. To do that, I just click Initiate. Okay, so I had a few open ports here. Port 25. But the only interesting traffic there. What about our router? If we scan our gateway, what would happen there? Port 25, port 53 for DNS, and port 80. So there's a little web server there. But you can see the basic functionality of our application and what it does. And again, I can just get my network data there. And it's all done in a separate thread from main loop, and that way our interface remains responsive. So you can call yours what you want, and you can add additional functionality. You could add packet capturing functionality. You could make this into some sort of Swiss Army knife if you want to, but to start out with, the idea was to keep it simple. So it's just a ping sweeper and a port scanner.
The Python Tkinter code.
So let's step through our code. We're importing various modules that we'll need, and of course our instance of tk.Enter, the toolkit, as tk. You could, choose whatever instance name or variable name you want to use there, but it looks like tk is sort of the traditional, for toolkit. So the first thing we need to do is get a context with which to build our tk.Enter application. A window, a frame. So that's what we're doing here. Window, you could call it anything you like. I just call it window usually in my tk.Enter apps. But I'm just getting an instance of, or building an instance of tk.Enter. Giving it a title. These are variables to set the width and the height of the window. And I use absolute positioning. So you'll notice down here, I don't let the end user resize the window. I haven't coded it to dynamically move things. You get more control when you use place in tk.Enter and absolute positioning. You get a lot more control over your widgets. But the downside is you don't really want to let the end user resize the window when that's the case, unless you code it very carefully. In this case, for screen width and screen height, I'm just getting that as a property of my tk instance. I have a variable here up here in the middle, and we just do a little bit of math the screen width minus the window width, this variable here, and the screen height, which we get from tk.Enter, minus the window height, which is this variable here. Divide them both by 2, okay? A little bit of a regular expression, and then we use the geometry method. This will cause that to appear in the middle. So that way, notice when we ran the app, it appeared in the middle of the screen. So that's all that's for. And we're just configuring the background here to be black. And we're initializing it. In this case, this will act as a pointer, sort of a pointer outside of our class, that once we initialize our window, we can then use it as a handle, as a context to access our window, our tk.Enter frames, and our main window, our parent frame. So it's just set to null, to none in Python. Our interface is defined inside of a class. And if we go all the way down here, you can see, all right, here's GUI. It was none. It was initialized to null. But now we're going to build an instance of PPPP GUI, or PPPPP GUI, and we're passing in window. Remember, window, that was sort of our pointer to the instance we built of tk.Enter. Pass that into the constructor as a parameter, and that way we can then use it to create widgets and manipulate things on that window background. And then, of course, to launch it, to bring up our graphical app, we just call main loop, and that brings up our main window, the parent, and all of the child objects, the widgets on it. Okay, so what is this? This is our class. Let me scroll way up here. All right, so PPPP GUI, in this case, this is our interface class, what we build our main window and add all of our widgets to. Okay, one thing you can do in Python that you can't do in other languages like Java and C++, you can nest functions inside of another. Now, in Java and C++, you can have member methods or functions inside of a class, so that's no different. But one of the cool things you can do in Python that you can't do in many other languages is not only can you nest methods and functions inside of a class, as those other languages allow, but you can nest a method or a function inside of another function. Or you can nest one inside of a class and then nest another function inside of that. So there are many different layers of scope that you can create or code into your apps and into your programs. But the first thing we want to look at, let's look at how we build the interface. All right, so we're going to...
The constructor of a class is always prefixed with 2 underscores and then the keyword in it, and then postfixed with 2 trailing underscores. Example.
Go down here, here's the constructor of our class. Remember that the constructor for a class is always going to be the keyword def to define, and then underscore, underscore, init, underscore, underscore. And you would almost always pass in self as an argument to provide context to access different data members, different objects defined in that class. And in this case, master as none. That will be the root context under which we build our window. This works a little bit different from Java or C++, where you would simply define the constructor with the same name as the class itself. But in Python, it's a little bit different. For a constructor for a class, it's always going to be underscore, underscore, init, underscore, underscore. Okay? And there are advantages to doing our interfaces inside of a class. As our programs get larger and more complex, it becomes more manageable to create or code classes and then instantiate our GUIs inside or from those classes. So we're just doing that here.
tk.Enter widgets listen for events that are triggers, such as a mouse click or key press. When a widget detects its trigger event, it calls its corresponding event handler method.
Now, we'll come back to this code, but all of the event handler methods we're going to want to define inside of our constructor. And remember, Python uses indentation to define scope. So in this case, here's all of our event handlers. These are the methods, the functions, that listen for different things the end user is going to do with our GUI. All right, and these triggers, once they're detected, these event handler methods get called, but notice we define them inside of the constructor of our class. Okay, so kind of remember that. Hold that in the back of your mind somewhere. But let's look at building our basic GUI. So here's the frame for the main window, and I commented all these sections out, hopefully, to make them easy to follow. So first we build and add the main window. All right, that's the master. Then we're going to add the title label. We add that to frame main window here. And button get host net data. Also add that to frame main window. All right, notice we're using absolute positioning with place here. And configuring the attributes, the height, the width, the border width, the relief, the background, and so forth. We're going to add a menu bar. That's the menu bar you saw up top. So here's the root of our menu. And once we do that, we're going to add some, the file menu, the view menu, the help menu, okay? And notice that we're associating as we go event handlers with each of those menu items, okay? So these all have event handlers, and they're all associated with that item. Let's take a look at the ping sweeper. In this case, it's a label frame. We place that on the interface, and then we have a radio button, activate ping sweeper, and that just calls RB ping selection handler. Okay, so there's an event handler when that radio button gets clicked or triggered. We've got a label for our ping sweeper, and then the start host and the end host. Okay, and then we have an entry here. Okay, and then this is where we get the end user can actually input a value. Another entry. So in this case, for the network, the start host and the end host, these are all tk entry objects. Again, we're placing them on the interface with absolute positioning. And then here's the button. Once clicked, it calls the event handler button init ping handler. Okay, so that's for our ping sweep. Our port scan is added to the window in a similar fashion. So we have a label frame, a radio button with the corresponding event handler. Once that event is triggered, it listens for that event. Then we have a couple of labels, and after that we have some text entry objects, in this case tk entry, to take input for the beginning and ending ports to scan, and then a button which again goes and calls an event handler. And then here's our main output frame, and we added a scroll bar to it, so that way if we're doing a long ping sweep or port scan, we could scroll up and down to see the results. And we used a text object because we can do multi-line output in that text object. It's better than an entry object, which would limit us. And then here we're setting the scroll bar behavior. And then in this case, just for the startup, we're going to, just sort of a graphical effect to show what the main output window does. We're looping here. So when we load our window, this loop will populate that text field with the values we see when we initially run it. Here is the network portion of the interface. Okay. And in this case, again, it's a text object and a label that labels that. And then these are the default load settings. So we're going to set the default radio button. And in this case, it's 1 or 0, true or false. And we're going to call RB ping selection handler and get current network. So let's go over these first. First we'll go over this item here. notice that in the radio button, RB ping or port variable, we've set the variable here in our TK radio button. We've also set it here for both the port scan and the ping sweeper. Okay, so this is how we set up a radio button to toggle on or off. And here we're using tk.Intvar, and this method will return to us a value based on what we set that value to. That gives us the initial effect. So again, if we run it, so if we run it, notice the behavior. What happens next? RB ping selection handler is called. And in this case, if we activate the ping sweeper, that's this method here. And this just disables, if we're selecting ping, then we're disabling the port scan functionality. Likewise, here's the port scan handler, and we're going to enable the port scan functionality and disable the ping sweep functionality. We just want to control what the end user does in our interface. And then we have, in this case, a ping handler, and that will simply call threaded ping sweep. So this process needs to be threaded, and that's if they click that button here. If they click the port handler button for the port scan, again, we're going to go call threaded port scan. So these are two threaded methods, all right? And get current network settings. In this case, as a subprocess, we're going to run ipconfig all, store that in IP settings, and then we would simply display that as a string value. Scroll back down here. Let's look at get the current network. Here, we're just going to use our socket module. We're going to get the host name of the machine. And then we're going to get ipconfig all. In this case, when we do that, we're going to initialize all of these values here to be specific settings. And inside of get current network, we're going to parse and go through IP settings, which we got, this came to us as a huge string from ipconfig all. So we're going to go through, and we're just going to parse that string and split and strip it and pull out the different parts for the IP address, the default gateway, the subnet mask, the DNS servers, and so forth. And then we're just going to assign those values. Alright, so when we run it, that's what fills in the information here. Okay, so let's look at our threaded processes. And we will go, let's do threaded ping sweep, right, the first one. So threaded ping sweep, it's a method or a function, and what does it do? Well, it's going to create a separate thread, and in that instance of a separate thread, separate from main loop, it's going to call ping sweep, the ping sweep method. Okay. it'll start that. So let's see what happens in ping sweep. In this case, we're going to clear the text in our main text widget, and then we're going to go through and set these variables here and get, in this case, the network, the start, and the end. Okay? So we need to get this information. This comes in as a string value. And we're going to build up a string here, initiating ping sweep, receive from GUI, network address, starting host, ending host. We're just going to display that in the main output. And the ping at first is nothing. And then IP parts is equal to net IP. Alright? And what is net IP? That's what we got here from our entry object, our tk entry object. So that's the network. So we're going to split it at the decimal portion of the IP parts, and then the network IP is equal to the IP part, the very first part of it, and 1 and 2. So 3 octets there, and the 4th octet is what we're going to sweep. Starting host, end host, getting the operating system platform. So we need to do things a bit differently depending on what our operating system is. In this case, if it's Windows, we're going to pass this command in. Okay, ping, and then the number of times. If it's Linux, on the other hand, we're going to pass this command in. So it just depends on the operating system. Get the starting time of the scan, time start, and again we have to parse or convert that to a string. And then we're going to delete, whatever text happens to be there, let's replace it with the new contents, the results of our ping sweep. And then here, for IP and range, starting host and ending host. So we want to loop through this process from whatever the starting host is until the ending host. Alright, so the range from whatever we start with to whatever we end with. And then pinging, clear the text, insert the text. And then in this case, the command will be the ping command that we specified up here based on the operating system. And then the address. And the portion, that would be changing would be the address. So, and the address portion. And that's the network IP, and then what we converted from the IP portion, so like the last octet. And then for line and list, we're just gonna see if there's a TTL, and we get an echo reply, we're just gonna display live. You could change that message to whatever, but I just chose live. And then when we're done, we've broken out of these loops here, then we're going to get another timestamp when it ended. And we'll just display that information, the scan completed in this case, that amount of time. So all this, again, it has to be done inside of a thread. Otherwise it would lock up our interface. So that's threaded ping sweep. Now what about threaded port scan? Here's threaded port scan. It gets called, and again, we have to run this inside of a separate thread so it doesn't lock up our interface. So for the port scan, we're again going to clear the text field, initiate port scan, insert our text into the text widget, the main output. Okay. Let's get a timestamp for when we start. The remote server is set to be the value of the host. we're going to use our socket module again, get host by name, get the start port, and get the end port. Okay, and in this case, we're going to say scanning remote host, and then we need to try, and we have some exceptions here, because it's, there's a potential we may not find what we're looking for. We may have errors and issues and whatnot. So what we need to do is we need to use our socket module again. Okay, we're going to set the default timeout 2.1, so it just helps it run faster in our port scan. And in this case, 0.1 second, and the result will be, can we make a socket connection? Okay, so on socket programming, if we can make a connection on that socket, the combination of that IP and that port, then it's listening. That device is listening on that port, whatever it is, 80, 25, 23, 21. If the result is 0, and again, we have to go for port and range, for port start and port end. So this is a repetitive iterating process. That's why we have to do it in a separate thread. Otherwise, it would lock up our GUI, and it would be unresponsive to the end user if we just tried to do all of that inside of the main loop. Okay. So we come down here, and then we're going to close the socket. If we were able to connect. Now we have some exceptions. So here we're going to provide for Control C. They can terminate it via the keyboard. And then here, if the host name could not be resolved, we're not doing a port scan on a valid IP. And then a socket error, couldn't connect to the server, not a valid IP, couldn't connect there. So just some possible exceptions that might be thrown, hence the use of a try block. And that's pretty much it. Again, all this code is on GitHub, so you can download it, copy it, load it up in Visual Studio, and step through the code bit by bit and see how it works.